Imagine a telescope in Chile, quietly scanning the sky at 2 in the morning. It is July 1st, 2025. The software flags something. Not a comet from the outer reaches of our solar system. Not an asteroid caught in a familiar orbit around the sun. Something else entirely. Something moving on a trajectory that does not curve the way objects in our solar system curve, because it is not bound by our sun's gravity. It is passing through. This is the third time in 8 years that astronomers have confirmed this. Something entered our solar system from interstellar space, and it did not come from here. We like to think of the solar system as our neighborhood, a bounded place, ours. But for the last 8 years, objects from other star systems have been showing up. Objects with chemistry we do not recognize, shapes we have never seen, trajectories that come from the deep galaxy and exit never to return. One of them may be older than our sun by nearly 7 billion years. One of them hit Earth in 2014, and we did not confirm it until classified satellite data was declassified in 2022. And one of them, the first one, accelerated through our solar system in a way that violated everything we understood about how comets and asteroids behave, and the debate over why it did that is still not settled. In this video, we're going to show you what these interstellar objects actually are, why the first one broke the physics of cometary science, why the most recent one may carry chemistry from a star that no longer exists, and why one of them already touched the surface of our planet. Let's start with the first arrival, and why it was not what anyone was expecting. On October 19th, 2017, the Pan-STARRS 1 telescope on Haleakala, Maui, captured something crossing its field of view that immediately didn't add up. The orbital calculation came back wrong. Not wrong in the sense of a data error. Wrong in the sense that no known object in our solar system could have this trajectory. The object was on a hyperbolic path, meaning it had arrived from outside our solar system, swung past our sun, and was already leaving. We had never seen anything like it. It was named Oumuamua, Hawaiian for a messenger from afar, arriving first. The problem wasn't just that it came from somewhere else. The problem was what it looked like, and what it did. Oumuamua was up to 400 meters long and roughly 10 times as long as it was wide, a cigar shape, or possibly a pancake shape. Nothing in our solar system, no asteroid, no comet, no chunk of planetary debris, has an aspect ratio remotely like that. It was tumbling through space, not spinning cleanly, catching the sunlight in ways that made its brightness flare and fade in a pattern we had never observed in any natural object here. But the truly unsettling part came later. As Oumuamua flew away from the sun, it accelerated, not because of gravity, not because of any visible source of thrust. When a comet passes near the sun and heats up, it outgasses, sending jets of steam and dust that push it like tiny thrusters and alter its speed. We can see that happen. We can see the coma. We can see the tail. With Oumuamua, there was nothing. No coma, no tail, no dust, no detectable gas. And yet, it was speeding up in a way that violated the expected path of a pure gravitational orbit by a measurable, consistent margin. This is not a theory. This is what the data showed. Multiple independent telescopes tracked it. The acceleration was real. In March 2023, astronomers Jennifer Bergner of UC Berkeley and Daryl Seligman of Cornell University published a study in the journal Nature proposing an explanation: hydrogen outgassing. Cosmic rays traveling through interstellar space can penetrate tens of meters into ice, converting up to a quarter of the water into trapped molecular hydrogen. When Oumuamua warmed near our sun, that hydrogen may have vented invisibly, pushing the object without producing a visible coma. Because Oumuamua was so small, the force was enough to alter its orbit. But not everyone accepts this. Physical chemist Niels Ligterink responded that laboratory and theoretical models show it is unlikely that sufficient hydrogen could accumulate in water ice alone to produce the observed acceleration. The debate is not resolved. We watched an object from another star system travel through our solar system for a matter of weeks, and our best explanation for its most basic behavior is still contested. It left before we could study it further. It is now beyond the reach of any telescope we have. Whatever it was, it is gone. If Oumuamua unsettled astronomers, the second interstellar visitor did something subtler, and in some ways more disturbing. It looked almost normal. On August 30th, 2019, Gennady Borisov, an amateur astronomer in Crimea, detected a new comet using a telescope he had built himself. Within a week, professional observatories had confirmed it was real, and trajectory calculations arrived at the same conclusion as Oumuamua: a hyperbolic orbit, an extrasolar origin, and interstellar speed. This was 2I Borisov, the second interstellar object ever confirmed. Unlike Oumuamua, Borisov behaved like a comet. It had a coma. It had a tail. The Hubble Space Telescope captured it at 110,000 miles per hour, trailing dust and gas as it rounded the sun, passing within 180 million miles of Earth. David Jewett of UCLA, who led the Hubble team observing Borisov, said it was really active, more like a normal comet. And then they looked at the chemistry. Borisov's carbon monoxide levels were far higher than anything seen in comets from our own solar system. Certain distances from the sun, carbon monoxide dominated its outgassing at levels that had no parallel in the thousands of comets we have cataloged here. This object had not formed where our comets formed. It had not condensed from the same material. It carried the chemical signature of a different star system, a different planetary environment, a different history entirely. In March 2020, Hubble observations showed something else. Borisov's nucleus was fragmenting. The object was breaking apart as it left our solar system. We watched a comet from another stellar system, built from the ancient materials of some unknown planet-forming disk, come apart in the sun's wake as it began its journey back into interstellar space, never to return. What Borisov confirmed, in a way Oumuamua couldn't, was that interstellar objects are not rare accidents. They are products of the same planet-building process that made our solar system. When giant planets migrate inward during the early life of a star, they scatter smaller bodies outward. Some escape the gravity of their home star entirely. They drift through the Milky Way for billions of years, and occasionally, by pure geometry, they pass through ours. Borisov brought us chemistry from a star we cannot name. It is now gone. There will be no second look. Neither Oumuamua nor Borisov prepared astronomers for July 1st, 2025. At 4:30 in the morning, the Atlas Survey Telescope in Rio Hurtado, Chile, flagged an object that had been moving through pre-discovery archival images since at least June 14. When orbit specialists ran the trajectory, the reaction from within the astronomical community was immediate. One researcher described waking up at 1 in the morning to messages from colleagues who were experts on orbital mechanics, saying this is definitely interstellar. This is for real. The object was named 3I Atlas, and it was unlike anything we had seen before. 3I Atlas entered our solar system at 58 kilometers per second over 137,000 miles per hour. This is not just the fastest of the 3 interstellar objects, it is the highest velocity ever recorded for any object entering our solar system. Its orbital eccentricity was 6.14. A perfectly circular orbit has an eccentricity of 0. Earth's orbit is 0.017. Even the most elongated comets in our solar system rarely exceed 1.0. At 6.14, 3I Atlas was not following a curve around our sun. Its path was almost perfectly straight. It was passing through, not visiting. The Hubble Space Telescope observed it in July and August 2025, revealing a teardrop-shaped cocoon of dust and gas around a nucleus estimated to be somewhere between 440 meters and 5.6 kilometers across. It was active, a genuine comet, releasing water vapor, developing a coma, and changing from reddish to green as its surface chemistry evolved in the heat of our Sun. In late 2025, XRRISM and XMM, Newton detected a diffuse X-ray glow around the nucleus, making 3I Atlas the first interstellar object ever observed in X-ray light. 14 NASA missions tracked it simultaneously, including Hubble, the James Webb Space Telescope, TESS, Parker Solar Probe, Europa Clipper, and others. NASA's Perseverance rover photographed it from the surface of Mars on October 4, 2025, approximately 18.6 million miles away. It is the first interstellar object ever observed from the surface of another planet. But none of that is the most unsettling fact about 3I Atlas. Using the James Webb Space Telescope NIRSpec instrument to analyze the comet's isotopic composition, specifically the ratio of carbon-12 to carbon-13 and the enrichment of deuterium in its water, a team led by Martin Cordonnier of NASA, Goddard estimated that 3I Atlas is between 10 and 12 billion years old. Our Sun is 4.6 billion years old. Earth is 4.5 billion years old. 3I Atlas predates our solar system by as much as 7 billion years. It was formed early in the Milky Way's history, around a star we cannot identify, in a stellar population that no longer exists in its original form. The home star of 3I Atlas may have burned out, gone supernova, and collapsed into a remnant billions of years before the first fish ever swam in Earth's oceans. This object wandered interstellar space for up to 12 billion years. It crossed our solar system in a matter of months. It is already leaving. Here is what most coverage of these interstellar visitors has missed entirely. You do not have to look at the night sky to find interstellar material. It has already reached the ground. On January 8, 2014, a small meteor struck Earth's atmosphere off the coast of Manus Island, Papua New Guinea, traveling at approximately 45 kilometers per second. It was about 1 meter across, roughly 460 kilograms. It burned up in 3 distinct flares, releasing energy equivalent to 110 metric tons of TNT, and its debris scattered into the South Pacific Ocean. The event was logged by sensors on a classified U.S. government satellite. No one paid special attention to it. It looked like a small fireball, one of dozens recorded every year. In 2019, Harvard astrophysicist Amir Siraj, working with his academic advisor Abraham Loeb, examined the NASA Fireball catalog and flagged something unusual. The speed and orbital trajectory of the 2014 Papua New Guinea meteor placed it on a clearly hyperbolic path, unbound to the Sun. The object had arrived from interstellar space. They designated it IM-1, Interstellar Meteor 1. The journal could not peer review the study. Key measurement data was classified. In April 2022, the U.S. Space Command released a memo confirming that the velocity data was sufficiently accurate to indicate an interstellar trajectory. The confirmation was buried in a government memo and received a fraction of the attention it deserved. But the material properties of IM-1 are the part with no clean explanation. Scientists calculated its material strength at 194 megapascals. The strongest iron meteorites from our own solar system have a maximum yield strength of around 50 megapascals. IM-1 ranked number 1 in material strength across all 273 meteors in NASA's entire Fireball catalog. The gap between IM-1 and the second-ranked meteor is more than a factor of 2. Whatever it was built from something harder than any space rock that has ever fallen to Earth from our own solar system. In 2023, the Galileo project led an expedition to the South Pacific, dragging a magnetic sled across the ocean floor near the estimated impact site. They recovered metallic spherules, tiny metallic marbles, sub-millimeter in size, along the expected debris path. Analysis found these spherules contain negligible amounts of nickel, which is inconsistent with meteors from our solar system. Other astronomers have challenged the methodology. The location data, derived partly from classified satellite readings, has been disputed. The debate is ongoing. But what is not in dispute is this. An object arrived from interstellar space, struck Earth's atmosphere, and released material over the South Pacific Ocean 3 years before Oumuamua, years before we even knew to name these things. So what does all of this mean? 3. Confirmed interstellar objects passing through our solar system in 8 years. A 4th that struck Earth before we even knew to look. Population estimates suggesting that roughly 10,000 interstellar objects may be moving through our solar system at any given moment, with at least one statistically likely to be inside Earth's orbit right now. Astronomers expected these visitors to be rare. They were wrong. Step back from the individual objects and look at what they are collectively telling us. Planetary systems form around stars throughout the galaxy. As giant planets migrate, they scatter smaller bodies outward. Some of those bodies escape their home stars entirely and drift through interstellar space for billions of years. The Milky Way is not mostly empty. It is threaded with the debris of planetary systems we will never visit, and that debris passes through our solar system constantly. 3I Atlas may be carrying the chemistry of a star that no longer exists. It spent more than 10 billion years in interstellar darkness before our sun's gravity barely curved its path, and then it continued on, already gone. It will spend another unimaginable span of time traveling toward wherever it ends up next. If there are astronomers anywhere in the galaxy with the instruments to detect it, they will see the same thing we saw, a comet from somewhere else passing through. The fact that we built the Atlas telescope, the fact that it was watching on July 1st, 2025, the fact that we had Hubble and Webb and a rover on Mars and 14 separate instruments trained on an object moving at 137,000 miles per hour. That is not a small thing. That is a civilization that learned to pay attention just in time. We did not go looking for these things. They came to us. From stars we cannot name, through distances that would take our fastest spacecraft millions of years to cross, and the universe keeps sending them. The question isn't whether anything is out there. The question is whether we're paying close enough attention to notice. If you found this video worth your time, consider subscribing. There is more coming on what the Vera Rubin Observatory is expected to find now that it is operational. We will also explore what happens when we start detecting these visitors before they arrive, rather than after they have already left.